Happy Thursday, boys and girls. Today is March the 11th. It is a Thursday, and we are going to look at our calendar grid, update our calendar collector, and then focus on solving some word problems that involve fractions and whole numbers. This will be the very first time that we start this word problem workout for the month, so I really want you to make an extra effort to follow along with me to think about some of the things that I'm saying and some of the models that we'll use to represent our thinking and to understand what's really happening in the situations that we're going to experience today. I will say that we are very close to revealing the function for our calendar grid, but we're not there yet. Maybe tomorrow. We'll see. So if you have an idea, great, hold on to it. If you don't, then I'm going to show you today's card and maybe you can think about what's happening. We know that the days up here, the numbers that are being put in it starts at 1, so it didn't start at 0. It starts at 1 and then it increases by 1 each day. So you put in a 1, you get out a 4. Put in a 2, you get out a 7. Put in a 3, you get out a 10, so on and so forth. And the numbers that are coming out are increasing by 3. So that's another hint for you. Let's look at today's calendar marker. Put in 11, you get a 34. I wonder what I could say about the relationship. I know that it is, 23 more than 11, but we're not talking that addition here for our program. We're thinking maybe multiplication, or maybe we're thinking multiplication and addition. All right, so that's our calendar marker for today. Let's look at our calendar collector, and we're going to spin first for you, second for me. Here we go. You guys got a half. Wow, look, you got 1 half twice in a row. Not sure how I feel about that, but that's okay. Oh, and it looks like I just spun for myself on accident. Oh, what's going on here? Okay, I'm going to just respin for myself. I was trying to drag this fraction. So now I'm going to spin for me. And I got 1/6. Should have just gone with what I accidentally spun, but that's okay. I want to make sure I am being fair, even though I like to win. You guys know I like to win. All right, so I need you to open up or get out your number corner books. We are going to be working on this worksheet today, which I believe is page 75 in your book. And we're going to work through it together for the most part. So I'll give you a moment to do so. Remember, we are solving problems this month that involve fractions and whole numbers. All right, are you ready? Awesome. So let's look at the very first problem, and I'm going to read it aloud for you. Gloria has 5 garden beds, all exactly the same size. She has flowers planted in 1/3 of each garden bed. What is the total amount of garden bed space planted in flowers? Use labeled sketches, numbers, or words to help you solve this problem and show your work. So, do you have any ideas or strategies? Ideas of strategies or models that you can use to solve this problem? Yeah. Well, she has 5 beds, and it's 1/3 of each of those beds. Awesome. So maybe we should draw 5 garden beds. Can you think of an equation that would match? All right, well, let's make a quick sketch. So while Ms. Trammell is doing this, I want you guys to do the same thing. I know that it's the same size, and I'm going to try to make it as equal as possible, but if I don't, then just chalk it up to my humanness. I'm so sorry. So here's 1. Here is 2. Here is Here is 4, and here is 5. So I tried really hard to make them all the same size, but it looks like maybe I didn't do a good job. I don't know, but that's okay. Now, we have 5 garden beds. How many flowers did she plant in each one of them? Good, she planted 1/3. So here's what I'm going to do. I'm going to represent 1/3 of this garden, which be about right here, maybe. So 1/3, 1/3, 1/3, and 1/3. Make sure you guys are representing the same thing in your workbook. So here's some flowers. Here's some more flowers. Here's some more flowers. Here's some more flowers. Here's some more flowers. My first thought is, why didn't she just plant start in one whole garden bed? But maybe she wanted to look like it was more flowers. I don't know. Interesting. All right, so let's estimate. What do we think? What do we think the answer might be? We have 1/3 represented for each one of these garden beds. What might the answer be? Okay, so if the flower sections for all 5 of the gardens were combined, do you think it's going to be more than or less than 1? For those of you who are having trouble estimating your answer, I just simply want to know, is it more than 1? Would it be more than 1 whole garden bed or less than 1? Good. It would be more than 1. How do you know? Yeah, we would take 3 of these to make 1 whole garden bed, and we have 5 of them. So definitely more than 1. Would it be more than 2, do you think? More than 3? Guess we're going to have to solve. So let's solve it. I'm going to write an expression, and hopefully you thought about this expression. We have 1/3 5 times, which would be 5 times 1/3 is going to give us how many flowers? So here is my equation, and I want you guys to solve for that. What are you thinking? How can I solve it? Good. I'm going to add a symbol here because hopefully you thought about it like this. 5 times 1/3 is the same thing as saying 1/3 plus 1/3 plus 1/3 plus 1/3. Did you think about it like that? And we know that when we're adding fractions with like denominators, then really we're only thinking about the numerator because the size of the piece is remaining the same. It's telling you how many of those pieces I have. And I have 5 of them, and they are sized in thirds. So I have 5 1/3 size pieces, which is 5/3. You got it. So I'm going to write that. 5/3. 5/3. Can anybody think about it a different way? Because I did ask you when you estimated, is it going to be more than 1 or less than 1? How can I break up maybe or think about my thirds in order to create 1 whole and then some left over? Watch what I'm going to do here. Didn't we say 3 of these would make 1 whole? So I'm going to write it like this. 3 times 1/3 plus 2 times 1/3. Because I have 2 over here left over, right? Are y'all following me? I hope so. That's a times symbol right there. Okay, so what do we know about 3 times 1/3? What is it? It means I have 3 1/3 size pieces, which is 3/3. And 3/3 is the same thing as saying 1 whole. Very good. That's why we chunked it the way we did. And then I have 2/3 left over. So look at my answer. 1 2/3, which is the same thing as saying 5/3, but in a simplified version. So how much space has she taken up for her flowers? Good. 1 2/3 of a garden. So one whole garden, essentially, and then 2/3 of another garden. Let's look at the second problem. I guess before we look at the second problem, I just want to make sure y'all recognize the similarities between these equations. 5 times 1/3, I added 1/3 5 times. Or I can chunk them and group them so I can make one whole, which is 3 of the 1/3 together, and then 2 of the 1/3. So I just want to make sure you're following me as I go through these, okay? All right, so let's look at number 2. Gloria mixes fertilizer with water every week and waters each of her garden beds with the mixture. Gloria mixes fertilizer with water every week and waters each of her garden beds with the mixture. Each garden bed gets 2/3 of a gallon of the mixture. How many gallons of the mixture does Gloria need to water all 5 of her garden beds? Use labeled sketches, numbers, or words to help solve this problem. Show your work. Okay, so I need you to retell this situation in your own words. Go. All right, she's watering 5 beds and each one gets 2/3. So what would my expression be? My equation. Good, I have 2/3 times 5 is going to give me how many gallons she needs. So can I draw the same picture that I drew earlier to represent my thinking? Absolutely I can, and as a matter of fact, I'm going to do that. And I want you guys to do that as well. And maybe you can pause this video so that you can have some time to figure out how you want to solve it. What are you going to do to solve for 2/3 times 5? Right, so I know I need to break up my garden bed into, or I can think about this as gallons, okay? So I have 2/3 of a gallon, and let me get my pen tool going the right way today. So I have 2/3 of a gallon for this bed, and then 2/3 of a gallon for this bed, and then 2/3 of a gallon for this bed, and 2/3 for each of the remaining beds, right? And I could shade them in just to make sure. I know you see thirds, but I'm only talking about 2/3 in particular. So here's my picture. You already have an expression. So I ask you, do you think it's going to be more than one whole gallon? Yes. Do we think it's going to be more than 2 whole gallons? More than 3? Guess we're going to have to figure that out. Now, in 4th grade, you guys are supposed to know how to multiply a whole number times a unit fraction, okay? And I hope that you know a unit fraction has a 1 in the numerator. So watch what I'm going to do in order to solve this problem. We think it might be more than 2, maybe even more than 3. Maybe more than 3, more so than more than 2. Because I can move one of these thirds here to make a whole, and then this other third here to make a hole, and that's already 2 holes right there. So maybe we'll even have more than 3 holes. Let's break it up. What do I see in this picture? Good. You should see a third and another third. So I have 1/3 plus 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 1/3, which is the same thing as saying 1/3. I have how many of those 1/3s? I have 10 of them. Or I could say we have 2/3 5 times. So let me break up 2/3 into my unit fraction. In each one of these gallons, I have 2/3, 2 1/3. Does that make sense? And I'm still multiplying that by 5. We good? Okay, so now I have a unit fraction to work with, which is what I really like to work with. Make sure I really understand what it means to multiply a whole number times a fraction. Now, there's a special property that says that we can move around numbers and then we can reassociate numbers together, like with these parentheses, when we're multiplying. So I could potentially do this. And instead of associating 2 and 1/3 together, maybe I associate my whole numbers together. And what is 5 times 2? 10. Did y'all hear Miss Trammell say earlier that we had 10 third pieces? Yeah, we do. And that's the same thing as saying 1/3. How many times? We're adding 1/3. Good. Now, if we were to add 2/3 5 times, we could do that. But it would be really hard for us to figure out where our holes are. Kind of like we said, we can move this third here and then this third here, which would take away this whole picture essentially because I'm moving it to create whole gallons. So I'm going to do similar to what I did up here, which is to combine for my holes. And before I do that, let me write out 1/3 10 times, which is not going to be fun, but I'm going to do it. That's 5, that's 6, 7, 8, 9, 10. Okay, here it is. Let me scroll over to give myself some more space to work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. Now, how many thirds make a whole? Good. Here's a hole. Do I have enough to make another hole? Absolutely. Here's another hole. Do I have enough to make another hole? Absolutely. Here's another hole. Do I have enough to make another hole? No. What do I have left over? 1/3. So how many holes did I make? How many whole gallons? 3 whole gallons. And then how many of another gallon? Not how many, how much of another gallon? 3 and 1/3. So my answer is 3 and 1/3. Or I would have gotten 10/3, which still is, essentially it's correct. It's just not in the most simplified version. 10/3 is like saying 10 divided by 3. So we can get 3 full groups of 3 and then 1/3 of another group. And that's exactly what I showed you here. So we will continue to work on word problems this month. I'm curious though to know if anybody doubled what you got from the first problem, because we did 1/3 times 5 and now we need 2/3. See, we double it. So if our answer up here was 1 and 2/3, we could double 1 and 2/3 and we'd still get 3 and 1/3. So there are a lot of different ways to solve a problem. Our job is to show you those different ways so that you can make sense of problems and think flexibly about numbers so that you can understand how to solve a word problem and to do it efficiently. That means fairly quickly and accurately every single time. So thank you for joining me today. I will see you guys tomorrow. Tomorrow is Friday. I love Fridays. And I hope you have a good rest of your day. Bye.